Hello, I'm James Ingram for AutoControls.org. This video number 824 is a continuation of the previous video number 823, and I'd ask you to refer to that previous video for more details about the detectors and other components used here. In the previous video 823 we ended with part 14, and this video starts at part 15. The previous video had demos 1 through 4, and this video contains demos 5 through 8. In the previous video, we were running one train point to point. In this video, we found we could use the same setup of a point-to-point track with a detector, with one of these detectors at each end, and actually run two trains on the same track. Each loco uses one of those detectors to establish its position, but it uses time delay to go the other direction, and we'll demonstrate all that. We can't use the two-button system shown in the previous video, where the public could actually push a button to run the train forward or push another button to run the train backward, but we still can use the one-button system we have here, that the public can push this button to initiate a back and forth sequence. Now, this video is primarily O-gauge. However, at the very end I tacked on a demonstration using two S-gauge locos, and that's what you're seeing here is how I finally finished the video. And as a note, to run the S-gauge, I just changed the locomotive numbers and changed the speed in the Mini Panel's little routine that controls the system to operate the S-gauge engines instead of the O-gauge engines. And as far as the system itself, what we've got here, again, I refer you to the previous video, 823, for the details, but we're using what's called an NCE brand DCC Mini Panel. The Mini Panel is a little device that can do automatic train control, and this is NMRA standard DCC we're using. We have an NCE Power Cab powering the system, and note that NCE does not recommend using the Power Cab for O-gauge like I'm doing, because it's too low of a voltage and too low of an amperage. However, it works for these demos here because I'm running slowly with only one train at a time and only one car, and thus I'm not using much amperage to do these demonstrations. Thanks for watching. Here's the same system we had before. I've just added two pieces of track to make it just a little bit longer, and I found we can actually run two trains on this thing without modifying the hardware otherwise. And I've turned off the sound on the Locos so the microphone will pick up better. And this can be run by the public as a push-button operated system. I'm going to go over and push the button right now. Now, pushing that button will initiate one complete cycle of operation, and you can see what's happening. The green engine is being moved forward to the end of the line until the Z-stop detector picks it up, and then that stops. Now, about a 5-second delay, and then the Mini Panel, that's the controller, will start the yellow engine, and it's moving that out by time since we can't use the detector, but we can say travel about 13.5 seconds out. Now there's about another 5-second delay, and then it will bring the yellow engine back, and this time we can come back to the Z-stop detector that's on the left end as we're seeing it. Now that engine stopped in front of that detector, and there'll be about another 5-second delay, and now the green engine is being brought back, and again we're using time delay. We just had the Mini Panel bring it backwards for about 13 seconds. So what we can do is use a combination of the detectors and time delays to keep these two trains operating without interfering with each other. Now notice it brought it back and parked it in the same place as before, and those two engines will sit there and wait again until somebody comes along and pushes the push button. Let's do that again. Now that'll initiate another cycle using that push button. Again, it goes down, the green engine goes down until it interrupts the infrared beam on that Z-stuff detector, which closes the relay, and that signals the mini panel that engine is at the end, and it gives it a stop command. Now it's running the yellow engine down, and again it's telling it to go about 13.5 seconds, which is enough time to get it down there but not bump the other engine. Now we've got about a 5-second time delay, then it'll turn around and come back, and this time we'll come back until that hopper car interrupts the infrared beam on the Z-stuff detector on this end, which also has a relay, and that signals the mini panel to give the train a stop command. We have a 5-second time delay, and now the green engine will start up, and the controller is telling it to come backwards for 13 seconds, which will bring it back to this end of the track, but stop it soon enough that it doesn't bump into the yellow engine. And there's a second complete cycle of the system. Now I've turned the sound back on those engines, and this time I'll go over and throw the switch closed, and that switch is wired in parallel with the push button, and that'll initiate the same process, except they'll keep running continuously. Here's our switch here. I'm going to close this switch. Now you can see the same thing is happening as before. The red engine goes to the green engine goes to the far end of the line and stops. Now the yellow engine is being brought out using a time delay. Now the command to stop has been given. There's a time delay of 5 seconds. All these time delays are adjustable to suit your preferences. Now the yellow engine is being brought backward to this end. It'll come back until it crosses that Z-stuff detector on this end of the track, which it did now. Now we'll have a 5-second time delay. Then the controller will start the green engine up and bring it back for, I think, 13 seconds to get it to this end of the track. Now when we use the push button, this is where it stopped. The system stopped and waited to do another cycle, but because we've closed that switch, it'll run continuously, so we've got a 5-second delay. Now you can see we're starting all over again.
Check that oil level.
This is the same thing happening, but the second cycle. We've got a 5-second time delay. The yellow engine's being started up. 13-second delay to run that out there. We're running both these engines at speed 2, which seems a nice, comfortable speed for the length of track we've got here. Now there's our 5-second time delay. The yellow engine's being brought back to this end.
We got a clear signal.
Okay, that engine was given the stop command. Another 5-second time delay. In a minute, there it goes. The green engine, the controller will start the green engine up and bring it back for 13 seconds. Now, when using the button, this is where the system would have stopped the trains and left them parked there, right there. But since the switch is closed, it checks and it says, oh, the program can tell that switch is closed, and it starts on a second cycle, which is what it's doing now.
Get me to check that out.
Okay, 5-second time delay. There goes the yellow one. That'll be run forward for 13 seconds. Okay, the stop command was given to the yellow engine. It'll sit there for about 5 seconds, and now it's been put into reverse, and it'll be brought back into reverse till it crosses a detector on this end. Now a 5-second time delay, and then the green engine will be brought backward. Now that'll sit there for 5 seconds, and then a third cycle will begin. There, now that's the third cycle, and that'll keep running repeatedly until I go over there and open that switch, and then it'll complete its cycle and come back and park. And let's do that right now. So we're still completing the same cycle, but the controller will bring the trains back and park them in their initial position once this routine completes. There's our 5-second delay. Now the yellow engine's being brought back, and it'll come back to the detector. And again, I hope you can see the scheme we're using here. We're using a detector on each end to stop one of the engines, and in the other direction we're using time delay. Now that engine comes back, that'll be brought back for 13 seconds. Okay, there's a stop command. Now since the switch is open, this time when it gets done at the bottom of the routine, it sees that switch is open, so it ends the little routine rather than repeating it. Now it'll wait. Those engines will sit there and wait till someone either goes over and pushes the button again or closes the switch again to start them up. If I go over and push the button again, you can see things started up again, and that'll keep doing that, all day long. We'll start the sequence. Now you remember in demos 4 and 5, we operated 2 locos, and we can do that with no change of wiring or anything here. I'm going to show the second loco, and now we're shown 2 locos, and the same hardware will operate 2 locos. This one, as you may recall from demo 4 or 5, this one will go down to the right end until it blocks that detector and stops, and then this one will go from the left end somewhere down here and stop, controlled by time delay. Then we'll wait a little bit, and we'll back this one up until it blocks this detector and stops, and then this one will back up from the west detector. We'll back it up until we have a certain amount of time delay and stop it. So we can use a combination. We can use the left detector for this engine and the right detector for this engine to sense when they're at the ends of the track, and then we use time delay to get them out in the middle. Now if you use this, you have to use button 1. You can't do this with button 2 and button 3, which is a public button, because you can't do the manual control because you can't sense where 2 trains are accurately enough to allow manual operation. So this has got to be button 1 only. And here's that routine for operating 2 locomotives like we saw in demonstrations 4 and 5. And going down to the bottom here to this little sketch, we recall we had our 2 locomotives sitting on the west end of the track, or the left end as we're looking at it. And what we did, we started the green one up and ran it down to the far end until it hit the detector. Then we started the yellow one up and ran it about 13 seconds on my layout until it got toward this end and stopped it. And then we backed it up until we got to the west detector on the left end and used the detector to stop it. And then we backed up the green locomotive for about 13 seconds till it got back to the left end of the track. In other words, we have a detector for keeping each locomotive oriented, traveling one direction. This one for the yellow, this detector for the yellow engine, and this detector down here for the green engine. And then we use time delay to run them the other direction. So going back up here, and what this denotes here, this little numbers, just tells what steps operate this engine for these engines for each part of the routine. Going back up to the top, we're going to, starting here with the commands, we're going to select Locos 779. That's the green one down here. And then we're going to turn the headlight on, same as before. Speed forward 2, that'll start it going to the west end. And then we're going to wait until input 16 is ground. That's until it crosses in front of the Z-step detector on the right end. And then we'll send a speed reverse 0 command to stop it. Then we'll delay for 5 seconds. And now at this point, here's our notation. Actually, we started out up here with 101. That's the yellow engine, and 779. That's the green engine. We started up with both of them on the left side. And after we executed these commands, 101 is still sitting right where it was, but 779 is moved down to the right end and stopped at the detector. So now the next part, we're ready to do the forward trip of Loco 101, the yellow engine. So now we say select Loco 101, turn the headlight on, speed forward 2, delay 13.5 seconds. Here's our time delay, because when we're taking that yellow engine to the right, we're not using the detector. We're just using a time delay to get it into approximately the right position. After the time delay ends, we send a speed reverse 0 command to stop the Loco, and we wait for 5 more seconds. Now, if we look at our positions at this point, you can see both 101, the yellow one, and 779, the green engine, they're sitting down on the right end of the track. Now we're ready for part 3. We're essentially halfway through our routine. Part 3 will bring the yellow engine, that's 101, from point B back to point A. That's back to the left side. So we'll say speed reverse 2, wait till input 14 is ground. That's telling us to wait until it gets to this west detector here. And when it does, we'll say speed reverse 0 to stop it, and delay for 5 seconds. So at this point, having completed those commands, 101, the yellow engine, is now sitting back on the left end in front of detector 14 on the left end, and 779, the green one, is still sitting on the right end. Now we'll do the last part of our routine to complete the cycle. We'll say select Loco 779, the green one, speed reverse 2, delay 13 seconds, then send a speed 0 command to stop it. Now we'll stop it toward the left end of the track, but before it bumps into the yellow engine. And then we delay 5 seconds, or whatever amount of time we want to spend sitting there waiting at the end. Then we do that same test command. We did it before to see if switch number 1 is closed or open. If switch number 1 is closed, it'll skip the next command, and it says link to 22, input 22, which takes it back up to the top, and it starts it all over, selecting the Loco, turning the headlight on, speed forward 2. And actually, these commands aren't really necessary, but it's easiest to put them in the routine right here. It doesn't hurt anything if the mini panel sends them repeatedly. Now, if the switch is open as before, if the switch is open, then it won't skip the next command, and it'll send a terminate command, which will stop the sequence. So at that point, the Locos will still be sitting where they started on the left end. They'll be sitting there with their lights on, the sounds idling, and in the case of this one with the rooftop strobe light, the strobe will be flashing. So we're getting all the animation, but the engine's not moving, and it'll sit there and wait. They'll both sit there and wait until somebody comes along and pushes push button number 1 to start them up again. Now here's this same system, but we've added a length of S-gauge track next to the O-gauge track, and we've jumpered the power from the O-gauge track via these jumper wires over to the S-gauge track, and the detectors are still being powered off the O-gauge track. If you jumped into this video at this point, maybe if I sent you a link to the S-gauge part or somebody else sent you a link to the S-gauge part, what we're doing is showing a demo of two locos running automatically point to point. This is tacked on the end of what is primarily an O-gauge video. We can start this running by using the push button over here, same as we did before. Now when I pushed that push button down, it started executing a routine, and these locos should make a single cycle down to the far end of the track, park there for a minute, and then bring themselves back and park there and sit there and wait until somebody pushes the button again. What happened is that red engine went down there until it crossed in front of the Z-stuff detector. That's an infrared detector. You might have noticed it went from green to red when the red engine got there. Now the gray engine's running down, and it's running under a time delay. It should stop about when it gets to that board in the track there. You see there's a white board sitting just to the right of where the locomotive is. Now that sat there for about 5 seconds. Now it's coming back, and the mini panel will bring it back until it crosses in front of the Z-stuff detector on this end and breaks the infrared beam, and you may be able to see that change from green to red. Now we'll wait about 5 seconds, and then it'll start the red engine up. It's on the other end. It'll bring it back, and it should stop about where that piece of wood is there. There's the near piece of wood, and the far piece of wood is down there. That's about where those locos are stopping. Now that's a complete cycle. They're going to sit there and wait and do nothing. They'll keep their, you'll have the headlights and taillights on and the flashing rooftop beacons, plus the sound will be on, but they'll sit there and wait until somebody pushes that button again to make another cycle. We'll do that now. If we use just one train on this system, we can actually use two buttons and set it up so the public can control it by holding down either the forward button or holding down the reverse button. And we showed that for the S-gauge trains in video 822 part 10. But here we're running two locomotives on this same track, and we don't have the capability to give the public two buttons to actually cause the train to move forward or backward, but we can give them one button, such as you're seeing over here, where they can start a cycle up, and it'll run through a complete cycle automatically. Now when that comes back again, it'll break that infrared beam that's coming out of that Z-stuff detector, which will cause it to change to red. That'll stop that loco. Now we'll wait about 5 seconds and start the red loco that's at the far end to bring it back. And that, like I said, that's running under time delay. In other words, we're using, notice each loco has a detector of its own to get it adjusted on the track, but we're making one direction, the trip one way, using a time delay. There, now they've settled back into their original position, and they'll sit there and wait until somebody pushes that button again. Now the other way we can run this is connected in parallel with that button. We have a switch, and if the operator closes that switch and leaves it closed, those engines will start that same routine, but they'll keep repeating it for as long as they desired. Now the switch is kind of hidden behind the gray loco, but I'm going to lean over there and close that switch. Here's the switch. I'm going to close this switch. Now it'll start executing the same routine as before, except when they come back to this end, instead of stopping and waiting for the button to be pushed, they'll just keep going. Now that that engine's out of the way, I'll show the switch. The switch is right here. The switch and that button are both connected to input 1. They're connected in parallel. You could have multiple buttons and multiple switches, but there's a little test in the routine that checks when they both get back here if that input is closed or if that input is open. And if the switch is closed, or if somebody would happen to be holding the button down, input 1 will be grounded and it'll repeat the sequence a second time. Okay, now here's this loco, the red loco, coming back, and when it gets up to this approximately where it will stop at that piece of wood, that'll be the end of the first cycle. Now there's a delay set in there of about 5 seconds. All these delays are of course adjustable, but it'll check, and you can see instead of sitting it started up again. Now we're starting up a second cycle. These locos, by the way, these are old S-Helper service locos, and they have Soundtrack Tsunami DCC decoders in them, and those are kind of nice because the decoder will operate the rooftop strobe lights without needing a special circuit, and you can set them to keep the headlight and the tail light on, both of those lights on all the time, which I kind of like to run them that way for displays. I want as many lights and action going all at once as possible. And the other thing you can set them to, and you can hear that, they give, if they sit long enough, they give 3 toots in reverse and 2 toots when they start up in forward, just like the prototype diesels would do. Now you may notice that gray engine just gave a toot when it stopped, and the red one just gave 3 toots because it's starting up in reverse. Now this is the end of the second cycle. Now the switch is still closed. There you heard the 2 toots out of the red engine when it started up forward. The switch is still closed, so it's starting a third cycle. In this, note this, we just shown this system working a minute ago for O gauge, and now we're showing it for S gauge, basically with all the same hardware. This system will work for N scale, HO, S, O gauge, or large scale, since it's all NMRA standard DCC. The only thing is you may need a smaller detector for N scale so the train doesn't sneak underneath the detector. Z-Stuff makes smaller detectors for both HO scale and S scale. And basically what's here, we have a NCE Power Cab over there providing power to the system. We've got an NCE Mini Panel, which is what's doing the automatic control. And then we've got Z-Stuff infrared detectors at both ends. And you could use a magnet at both ends, or you could use a electric eye at both ends. It just seems the Z-Stuff detectors are a little more convenient. Once they're wired up, you can move them around and reposition them real easy. Now this is the end of the third cycle. I'm going to go over there and open the switch. Now I just opened that switch on the operator's, what I call the operator's console, and now when that third cycle completed, it checked and input 1, the switch was open, so it goes into the idle mode and it sits there. And then it'll wait until somebody pushes a button or pushes a switch, and then it'll start up again. We'll just take a quick look at the system now that the S-gauge track has been added in here. Just starting at the near end, I've jumpered these two wires here are jumpering off the O-gauge track down here, and this yellow and black wire runs over to the S-gauge track, and that's how I'm getting power from the O-gauge track over to the S-gauge track. And the Z-stuff optical detectors, infrared detectors, they're still connected to the O-gauge track as they were before, so they're getting their power off the O-gauge track, but at this moment they're detecting trains on the S-gauge track. And then over here is our push button that says push and release to make one forward and backward trip. We can use to initiate an automatic cycle. Going down here we have the mini panel, that's our automatic controller. Reset button, switch number 1 we can close to cause it to keep making multiple cycles automatically. And then continuing on down, here's our MTH track connector that puts the power into the O-gauge track, and that's coming off the Power Cab. Here's the NCE Power Cab, and then down at the far end we have a second Z-stuff infrared detector. And you know, when the beam is broken by my hand or a train, it causes it to change to green to red, which controls this relay. I think you may be actually able to hear it clicking. And when that relay closes, that sends a signal down the wire, and actually all it does is connect these two wires together, ground them, and that wire goes back here and over to the mini panel. And that's how the mini panel, which is our little $49 automatic train controller, that's how it controls these trains, be it O-gauge or S-gauge or any other scale and any other brand, as long as they correspond to standard NMRA DCC protocol.